Hello everyone, welcome back. This video we're going to discuss multi-dimensional arrays and arrays of arrays, which are oftentimes called jagged arrays. They're slightly different, but we'll cover that. So what we have defined is some sizes and this, which is a two-dimensional array. So two-dimensional, meaning it has two dimensions. So a simple example, of course, as a table, you have columns and rows, or rows and columns of data, like a spreadsheet. I'm sure you've seen it many times. So what we want is we want to say we want 3 rows, 4 columns, and this will establish that for us, right? So this is an array of this number of columns, rows, which is 3, and columns, which is 4. So that kind of defines our grid, right? Think of it as a grid. And I've provided this starter value, which we're going to see. We're going to do some fun stuff with. And this is a jagged array. So jagged array is slightly different. As you'll notice, we are doing more work here with the jagged array. It's kind of a different, it's not as nice. So we are tracking the size of the array, which is 4. We initialize this array pointer with that size of 4. So up here it would be like this. It's slightly backwards, but it would be as if we define this as 4 for this, right? So we have 4 rows in this case, and then for each of those we're going to keep track of the sizes of each individual array, which would be the columns, because they could be different sizes, but we can't go in and do the same magic of finding the size, at least not with this approach. There are some more modern approaches which I'm not covering in this video, explicitly trying to cover this just to kind of show how it used to work and what you'll likely see out in the wild. So anyhow, you have to keep track of these sizes because getting that information later is not easy. You can do it, but it takes extra work to get there. So we're doing that up front. We're keeping track, and here we're going to loop through for our 4 rows, and we're going to define ourselves dynamically a new array, and we're doing array of sizes. So for this index, so 0, 1, 2, 3, right? So the first one will be an array of size 2, the next will be an array of size 4, and then 5, and then 1. So it'll be 4 rows, and then the first row will have 2 columns, the next one will have 4 columns, etc. So not quite a table, because it's not a nice rectangular shape. It is jagged. So again, we have kind of mixed things. An array of arrays or a jagged array is the kind of not lingua franca, but the what you'll hear it called. So you can hear, those are interchangeable. So anyhow, that's what that is, defining that. We'll get to that towards the end, but it's defined here, so I reviewed it. So then here we have for our first example here, again, our table. We're talking about the size of the rows, and we covered this in another video, but we're getting the first one here, and then this is how you would get the second dimension. So notice that we're getting the size of the first item, first index of that, which is actually the size in bytes of the first item. So because of the type, it can say, okay, say it's 8 bytes. Now it knows the size of those bytes, and then we're dividing that by the size of bytes of that thing's first item, right? And so that's how we're getting the size. We're dividing those up. Knowing that, you can kind of understand how this doesn't quite work because it's not uniform, right? One index may not have the same size as the other, so it doesn't quite line up the same. So we're going to print those out just to make it easy to see, and then we're going to populate that with some values. Then we're going to print those as numbers, and we'll see a nice little output there, nice little table. And then I thought it would be fun, we can output some chars. So you'll see those same numbers converted to characters. So you'll see some letters. And I'm casting here using a static cast, but I'm also going to show you that this is another way to cast, the older style. And so let's go ahead and take a look. Run and see how that looks as we execute. Okay, so we got our size of rows, size of calls, which is right here, right? So although we did define these up here, rows and columns, right? The sizes we actually collected from here, ensuring that, hey, we said we wanted 3 and 4, we got that, right? So that kind of verifies that this is doing the work that we expect it to. And then we're populating, and then we're printing the numbers. Okay, so we start at 65, and we printed out 3 columns and 4 rows, right? Then we did our magic, converted those to chars, so you can see the A, B, C, D, E, F, G, etc. And so that's great, right? You can kind of understand how a 2-dimensional array will be very valuable for something like this, like a table, or something that has a matrix of data that's important to have positional elements, right? So think of like a game. You could use this for a game, so like chess or checkers or any kind of thing that would be laid out or use a grid kind of a structure. This could be useful. Just so as an example, I'm going to comment this out and reveal this one to the world, and we're going to execute again to show that it's doing the same thing. It's just a different style of cast. This is an older style. This is kind of the more preferred method, using a static cast here. But you can see that they did the same thing. This is, if you see this, that's kind of the way that you'll probably see a lot of in code out there. Okay, so that covers the 2D array. So it's a nice rectangular formatted data. When you define this, it kind of claims that whole grid for you, right? So you got your 4x3 that is saved for you. That's defined. That those are all going to be ints, and we're going to be using it. So you're kind of reserving that, right? Now with the jagged array, it's different. Now we're saying we don't know. We know that we're going to have 4 of these things, but we didn't tell it at the beginning what these things are going to be. We're actually creating them at runtime, and their sizes are different, so we don't know ahead of time. Because of this, how we're using the new keyword there, we do some cleanup. So I'm going to skip down to the bottom here, and let's rehydrate our code here. And you can see I have a little cleanup step, so we're deleting those because we've created them dynamically. So now for our jagged array, what we're doing here is not as interesting as the columns, but we set a counter, and we're going to count up the numbers so that you can see that they are not nice and rectangular, that they will be in fact jagged when we print them out. You'll see some of that. Okay, so let's take a quick look here. Okay, there we go. So as you can see, we started at 0, and then for each one we added 1. We just did a plus here. But you can see, so this one was 2, and then 4, and then 5, and then 1, right? Exactly what we defined up here in our sizes, 2, 4, 5, and 1, right? And so there's uses for this as well. So you don't always have a structure that suits like a grid type of layout. Maybe you have a collection of this thing that you're, every part of the array may have a different set of values for whatever reason. So it doesn't have to be defined as a perfectly rectangular shape, clean piece of data. But this array of arrays is a little bit more to handle, as you can see from the manual tracking of the sizes, and it takes a little bit more, and by being dynamic we do have to do some memory management. So that's kind of the gist of the two. There are more. You can do more dimensions. This is just a 2-dimension, but you can get into very complex territory, and so you have to be careful. The the more dimensions you have, the more difficult it can be. If you're familiar with 4th and 5th dimension in physics or whatnot. Let's not go down that road. Let's end it here. Hopefully this has been informative, helpful, and not too confusing. And I guess that's it. Thanks for stopping by, and see you in the next video.